Okay, inequalities and interval notation. So far what we've been talking about in this class is we've been talking about different types of functions. We've talked about polynomials, we've talked about rationals, which is basically functions in terms of a fraction where the top and bottom are polynomials. We've talked about radicals, which is stuff with roots. And we've talked about exponentials, both if you have the variable in the exponent or the base. And then we've talked about logarithms and then trig functions. Okay, but as we've seen for some of these functions, they're not defined everywhere, sorry. So a log, for example, we can't have log of negative numbers. So talking about restrictions of these functions and where they are defined on the Cartesian plane is going to be very important. And we need an easy way to do that. So an easy way to communicate where things are defined and where they're not defined is by using intervals. Okay, so we say, you know, x is allowed to be here to here. And to do so, we need to also discuss inequalities. So we're basically trying to build up mathematical vocabulary to quickly be able to say something. Okay, so inequality notation, let's start with this. So in English, if you say a number x is less than another number y, a fast way we can say that is to just put, this is called like a less than value, less than, okay? And most of you in high school probably learned the Pac-Man thing, that whatever way it's open, that's the bigger part, the part that the Pac-Man eats. I hope they're still using Pac-Man. Let's see, I'm getting... So if a number x is less than or equal to another number, so it's maybe equal to, or it could be less than, you still have that little triangle, but you also put a line underneath it. Okay? Now, if a number is greater, so if a number x is greater than another number y, then the way I put the triangle is the opposite way. Okay, I'm going to go x is the bigger thing, so triangle opens up towards the x. If something is greater or equal to, same idea. So Pac-Man is toward the x, and I have to put a line underneath because maybe x and y are equal to each other. Let's say a number is between two numbers. So like the number 3, for example, is in between 1 and 5. Okay, if you want to write that out, it's less than or equal to here, less than or equal to here. So basically x potentially could be equal to y or z, or it's a value in between them. So in the case where they're definitely not equal, so x is never going to be y, x is never going to be z, we don't put the lines there, we just leave the triangles on their own. In terms of terminology, sometimes they're referred to as endpoints. Okay, so if you ever see that in a book, sometimes we call these endpoints. And both inequalities may not include the endpoints. Sometimes they do, sometimes they don't. There's equivalent statements that we can make instead of using inequalities. Or we can also graphically represent this information by using a number line. Okay, so let me flip over here for a second. Now, in interval notation, we have two main types of intervals. We have something called an open interval, or open brackets, a closed interval, or closed brackets. And in terms of what they look like, open intervals or open brackets are rounded. Closed ones, they're square brackets. Okay, and the first one here, the open ones, this does not include the endpoints. So does not include endpoints. If you have square brackets, the endpoints are included. Include endpoints. So if both endpoints are included, we have closed brackets. And again, in terms of vocabulary, we call this a closed interval. If our endpoints are not included and we have open brackets, this is called an open interval. And situations where one of the brackets is open, one of them is closed. It doesn't matter if the open one is on the left or right. These are called half open intervals. So the 4 different situations you have are the case where both of the brackets are open, okay, which means that A is not included in our interval. So if we say that X, this notation here means X is an element. X is an element in the interval AB. So if X is in here, A and B are not included in this situation, and this type of interval is an open interval. If you have the case where one of these intervals is open, one of them is closed, so this means my A is not included, my B is included, this type of interval we can say is a half open. Same thing with this next one. Half open, but this time the A is included and the B is not included. And then the last case here, I have square brackets in both situations. Both of these are possibilities. It is included. This is called a closed interval. Remember, infinity, positive or negative, it's not a number, it's a concept. Okay, so we always use open brackets if we're talking about infinity as one of those endpoints. So an open bracket, this is very important. A lot of people, including myself, originally when I posted this, somebody found my little oopsie, so I appreciate that. Okay, open brackets are always used for negative infinity and positive infinity. And we're going to see a couple examples like that. Now, graphically, I think graphically seeing these things really helps people. So in terms of if we wanted to plot something, if we want to say X is between two numbers and plot it, we use open circles and closed circles. Closed circles means includes, open ones mean not includes. Okay, so now let's look at these relationships. So say that you have the first one. So X is greater than A. Okay, what does that mean on a number line? Hang on, let me just see how big my head is compared to this. Okay, so it's a little bit hard to see, but there's 0 here. I've called A here, B here, negative A here, negative B here. Okay, so X is greater than A. So X is not equal to A, so that's why I have an open circle here, but it can be anything between A and infinity. Okay, if you wanted to write this in interval notation, the infinity always has to have a rounded bracket, and because we're not including A, this is also a rounded bracket. In the case where A is included, we would still draw the same thing, but our circle would be colored in, and I would have a closed bracket here, a square bracket, because it's included. Opposite direction, so if I'm saying that X is going to be less than A, so it's going to be some number in between here, open circle, and it's allowed to be anything in here. And in interval notation, it can be a very big negative number, okay, so open bracket for negative infinity, not including A. But if I include A, I have a closed bracket here, and I have to color this in. A and B, not including A and B. So A is here, B is here, open circle can be anything in between here. If you prefer interval notation, open brackets. If you include, say, A, okay, we're still anything in here, including A, so this becomes a colored in circle, and now I got to change that to a closed bracket, and because it aesthetically pleases me, I'm changing that to be blue. If my endpoint B is included, but A is not, again, this one's open circle, this is colored in, open bracket, closed. And if A and B are both included, you have these squared endpoints. Now, for people who have, in English, when we write the inequality like this, this secretly means, I'm going to zoom in here for a second, this secretly means that we can say X is greater than A, or A is less than X, whatever you prefer, and X is less than B. So this is another way that you could write this notation, okay? But when it's grouped in as one inequality, in English, it's something called logic in mathematics. And or mean very precise things about statements that are true and false. Okay, so if you see and, you can rewrite an inequality to look like this. Now, in the case where we have or, so either x is less than a or x is greater than b. So it's two separate inequalities. I cannot put them together in one. See how ands, they were only one line and it was in between 2 points? Or is when you have a point negative infinity and a point then to positive infinity. So if we have x is less than a, not including a, so open circle all the way down here, or x not including b is greater than b, this is what your plot then looks like, okay? And in interval notation, the thing about or then that you have to be careful of is we have to split up the interval notation of it. So I'm saying that it's possible x can be here, which means negative infinity to a, or that's what this is. Okay, it's also referred to as union or b to infinity, not including these. Okay, so they're open brackets. Similarly, if I include one of my endpoints, so the first one I include a, the second one I include b, okay, my circle for the a part becomes filled in. For the second one, my circle for the b part becomes filled in. And I just have to change the bracket now to include a for the first one. And for the second one, I got to change it to include b. In the case where x is less than or equal to a, or x is greater or equal to b, then these circles become filled in. I still have to split up my interval into two parts, and then u. And graphically, it's sometimes easier to figure this out by first graphing it. When you have a gap in between, that's when you use this u or this union. Properties of inequalities. Okay, so for properties, if we have another number is less than another number, blah, blah. See, I'm getting tired too. So think about like a as 2 and b as 4, okay? If I add the same number to both sides, or subtract them for that matter, so plus or minus c, this inequality still holds, okay? If you have that a is less than b, and if c is greater than 0 and you're multiplying, this still holds true. Okay, but, and remember, multiplication, c can be a whole number, so 2, for example, but it can also be a half. So it doesn't matter if it's a fraction or a whole number, this property holds true. So in the notes, I'm probably going to change this to write it like this. So if you multiply by a negative number or divide by a negative number, your sign flips. Now let's try to do a problem. Let's see how it works with some numbers. So solve the following and draw a solution. So we're going to talk about the interval notation, the inequality notation, and the number line notation. Okay, so we have this inequality where we're told that 4 minus 3y is less than 7 plus 2y. We're going to bring all the y's onto one side and all of the constants onto another side. Okay, so because I want to avoid negatives on the one side, that's fine. You can pick whatever you want. I'm going to bring my y to come on this side. Okay, so I'm going to have my 2y plus 3y, and 4, I'll bring the other constant term to this side. So I will have 4 minus 7. So now I'm going to have 5y here, and then I'm going to have negative 3 here. And I still have to isolate for the y, so I'm going to divide through by 5. Okay, or if you don't like this notation, it's the same as writing y is greater or equal to negative 3 over 5. So I'm going to put negative 3 over 5, so that's somewhere on the left of the 0. I am including the negative 3 over 5, so y can potentially be that number or anything above there. So y is somewhere in between here and here. In interval notation, if I wanted to write that, y is somewhere in between negative 3 over 5, including negative 3 over 5, and infinity. So square bracket, rounded bracket. When you see something like this, the goal that you want to have is to always isolate for x and to have it in the middle. We have this negative 2, 5 plus 3x, and 20. Now, for inequalities, it's almost like we have three separate parts here. So when I say I want to get rid of the 5, subtract it off, I'm subtracting it off in this part, and this part. Okay, so I am going to have -2 minus 5, so -7 on the leftmost part. I got rid of the 5 in the middle, and then on the right side, I have 20 minus 5, so I have 15. And now I'm almost there. -7 over 3x, 15 over 3. And we can simplify it a little bit. -7 over 3x, 15 over 3 is equal to 5. Now notice here that my equals, I don't have them, okay? It's strictly in between -7 over 3, 5, not including those endpoints. So this time, graphically, I have -7 over 3, okay, wherever that is. And then I have 5 over here somewhere. So I have an x that's in between these values, not including the values themselves. If I wanted to write this in interval notation, x is somewhere in between, not including my endpoints, -7 over 3 and 5. So we have x squared minus x less than or equal to 12. Just like we would if there was an equal sign here, I'm going to bring the 12 over to the other side because then I can factor it. Okay, so if I do that, I have x squared minus x minus 12 is less than or equal to 0. If I factored that, okay, multiples of 12, we could have 6 and 2, but that doesn't seem to work because the middle is a -1. So how about we do -4 and 3, +3. For a type of question like this, I have to split this up into different cases now. The first thing I want to do is I want to look to see when this is actually equal to 0. Now, why would I want to do that? I want to do that because it tells me how much I have to split up my interval. Because originally, think about it as starting from -infinity to +infinity. Okay, the two places where it can be equal to 0 are x is equal to 4 and x is equal to -3. So I can put little circles here. +4 and -3. So these points right here are included, and it's telling us I can split up my interval into 3 different parts. I have my first part here, which is going to go from -infinity to 3. I have my second part here, where it's going to be between -3 and 4. And then finally, I have my last part where it can be 4 or above. But I don't know if all of these parts are going to be included. But it's telling me that I'm going to have to check to see if I pick a number in this green spot, will it be less than 0? If I pick a number in between -3 and 4, will it satisfy this inequality? And similarly, if I pick a number between 4 and infinity, will it satisfy this inequality? And this is almost like a guess and check process. Okay, so we have 0 at 4 and -3. This splits up our number line. Into 3 main sections. Okay, so my first section, as I said, it's going to be between -infinity and -3. Now, so pick a number, whatever number you want. So say I pick -4. Okay, I'm going to put -4 into the equation that I have above and see what I end up getting. So I'm going to get -8 for this part, and I'm going to get -4 plus 3, this is -1. So negative times negative, this is a positive value. I'm getting that it's greater than 0, not that it's less than 0. So it is not included. So this here, not included. Why? Because we want this here, this x minus 4 times x plus 3, we want it to be less than 0. Let's look if we're in between -3 and 4. Okay, typically I pick 0. If you can do 0, pick 0 because it's faster to actually plug in the numbers. So in my first term, I get -4. My second term, I get 3. -4 times 3 is -12. And is that less than 0? Yes, it is. So this is good. Happy face. This is included. Okay, finally, last but not least, I want to check between 4 and infinity. Okay, and again, I can pick whatever number I want. I'm going to pick, say, 5. You can pick much bigger numbers, which may also be good to more easily see, but just so people can get used to the idea here. I have 5 and I have 5, and then I'm going to end up getting 1 here times 8. 1 times 8. Again, this is a positive value. This is a no-go. I don't want positives. I want it to be less than 0. So we say that this inequality is satisfied within the following. So my -3 is okay, my 4 is okay, and everything in between there is fine. But because I'm getting positives both here and here, they are not included. So my final number line will look like the following. I'll have a -3 here, I'll have a +4 here, I can include these in my interval, and then I have a line. Okay, so this is inequality notation. This is the graphical notation. And finally, if I wanted to do it in interval notation, I'm going to be using square brackets because I'm including my endpoints. Let's do another one. Okay, so this one looks even a little bit more scary. Okay, but don't let it freak you out. Let's try to factor it. So even though there's a cubic here, we're going to take a big sigh of relief because I have an x in every single term. So I can factor an x out. Okay, so I have x squared plus 2x minus 3. Can I factor these two parts? Yes, I can. I can factor this. And if you have a hard time seeing this, you can always use the quadratic equation, okay? So x times x plus 3 times x minus 1 is greater or equal to 0. I can have x is equal to 0. I can have x plus 3 is equal to 0. Or I can have x minus 1 is equal to 0. So this is giving me 3 solutions: 0, -3, and +1. I'm going to have 0 here. I know that I have something when x is equal to 1. I know I have something when x is equal to -3. That's when they're equal. So basically, I have little circles here at 0, here at 1, and here at -3. So that means that I have a section from -infinity to -3. And then I also have a section from -3 to 0. Okay, that's my section 2. I'm going to write this in here. -3 to 0. I also have a section between 0 and 1. Okay, still a lot of numbers between 0 and 1, infinitely many in fact. And then finally, I have the section from 1 to infinity. Okay, so I have 4 separate sections there. So this splits up our interval. This splits our interval into 4 sections. Okay, and again, we can pick any number. Okay, so for my green section, let's say I pick -4. Okay, it's less than -3, that's fine. So I'm going to put in -4 into all my x spots, -4, -4, -4. Excuse me. And then I'm going to end up getting -20. Okay, what is -20? -20 is definitely less than 0. But is that a problem? Do I want that? No. I want it to be greater or equal to 0. And I've already looked at the equals parts. So this, not included. No go. Okay, now let's pick something in between -3 and 0. Okay, 1s are always nice to pick. -1, -1, -1. So I end up getting, for this one, I'll get a 4. This is good. This one is greater than 0. Okay, so we're happy here. Something between 0 and 1, probably a half. You don't have to, you can pick whatever you want, but to me that seemed like the easiest one to use. A half, a half, a half. If you multiply those things out, Okay, you have to find a common denominator. Okay, so for this one, you're going to have to go times 2 divided by 2 times 2 divided by 2. If you multiply it out, you should end up getting negative 7 over 24. But this is a problem. Less than 0, we don't want that. Not allowed. And finally, something between 1 and infinity. Let's say that I pick 2 and I plug 2 in. 2, 2, 2. I multiply those things out. I'm going to end up getting 10. This is greater than 0. This is good. This is allowed. Our inequality satisfied in 2 intervals. So we saw that our negative 3 to 0, that was fine. And remember, it included those points because we had greater or equal to. And we also saw that the last interval, 1 to infinity, was also fine. Okay, but now we have to write this in condensed notation. So because I want both intervals included, negative 3 and 0, as well as 1 and infinity, that's where I use this or this union notation. Okay, and then in terms of what it looks like drawing-wise, I have 1 here, negative 1, negative 2, negative 3 here. Let's fill in some little bubbles. Okay, and then I said here and up, that's good. And then between negative 3 and 0, that's good. Other things not included. So now let's do one where we're dealing with a rational function, okay? So we have to consider 2x minus 3 over x is greater or equal to 1. So especially if you're dealing with rationals, we have to be careful because we have a bit of a problem here already. X cannot be equal to 0. That's not allowed. So secretly, we've already split up our interval. We have already put something at 0. Okay, we're not allowed to have that 0 point. So I'm going to draw an open circle right here. Now for rationals, what we do is let's consider the case where it's equal to 1. I can't factor anything. So I want to see the case where it's equal and I want to solve for x. So I'm going to cross multiply. I have 2x minus 3 is equal to x times 1. I'm going to bring my x's on one side. So I'm going to get 2x minus x. Bring the 3 to the other side. All right, that's fine. So I now also know that at 3, I have that value included. Okay, so let's draw a closed circle. And to stick with the people who are very visual learners that like colors, we'll do an open red circle here. So I've split up my my interval into now 3 different sections. So we split up our number line into 3 sections where we are between negative infinity and our 0, not including 0. And then I have my pink color here in between 0 and 3. Okay, so I'm going to put between 0 and 3 here. And then my last section, I'm going to have that between 3 and infinity. Okay, 3 and infinity, and that's on the next page. Hang on, let me do this, and then I'll jump back. 3 and infinity. All right, so this is my little number line here. So again, we're going to pick some number in between negative infinity and 0. Okay, I'm just going to pick negative 1 because 1s are easier for me to work with. So negative 1, negative 1. This is going to give me negative 2 minus 3, that's negative 5 over negative 1. The negatives cancel, so this is equal to positive. Okay, is this greater or equal to 1, which is what we want in order for this to hold? Yes, it is. So that is good. So this is greater or equal to 1. We are happy. I saw my nephew not too long ago, and that's his thing now. Is Dr. Nell happy? Yes, Dr. Nell is happy. It's very cute. Sorry, random thought. See, I've been doing math for too long as well. Between 0 and 3, again, I like 1. 1s are easy. I'm going to plug in 1. So 2 minus 3, negative 1, and then I have 1 on the bottom. So this one is negative 1. It means not included. Between 3 and infinity, so I pick 4. Okay, so I'm going to sub my 4 into here, 4 into here. This is equal to 5 over 4. 5 over 4, yep, this is greater or equal to 1. So this one is also good. So our negative infinity to 0, but not including 0, was fine. And we also had the 3, including 3 to infinity. We also just saw in orange there that that's also fine. So in terms of the condensed interval notation, x can be an element in either somewhere between negative infinity and 0, or 3 to infinity, okay, including 3. So for my number line, I have 0 here, I have 3 here, okay, I'm including 3. I am not including 0 because it was irrational. And then I'm going to draw a line between negative infinity and 0, not including 0 was good, and 3 to infinity, including 3 was good.